Hello, mentors. Let's explore Illuminations. And this is a very interesting puzzle from meeting 5. So let's create a lantern design with gems or, any other object, favorite object. It will look like a cylinder with a square grid. Fold the sheet that you will receive to paste, identify the two sides of length 10. So we're going to understand what it means. So we just fold this. You have this piece of paper, and you fold so that the grid points or the lines here are totally pasted. So you end up with this roll thing. Let p equals 4. We call this a parameter. A parameter in mathematics is just a value that sometimes starts just like that. But when you try to generalize, it can change, and some things will stay the same, some things will not stay the same. Place several gems at some of the grid points so that every other grid point is at a distance of p units or less from one gem. See the examples on the grid. So we have a very funny distance, which is called the taxi cab distance, for example, between these two pair of points. This was the gem and this was another point. The distance is 3. You can go like a ladder, 1, 2, and 3. You could also use different paths. You could use, for example, this path 1, 2, and 3. Let me draw it again. For example, here 1, 2, 3. So no matter how you do the path, the minimum distance will be 3, right? The minimum you can do 1, 2, 3, or 1, 2, 3. Let's do another example between these 2 points. The distance, yeah, they're more far apart, so the distance it's 1, 2, 3, 4, 5, 6, and it's independent on the on the path as long as it's the shortest path. 1, 2, 3, 4, 5, 6. So you would say that these 2 points in the grid are 6 units apart. So this is a funny distance. But now here comes the interesting part, is that since you folded this, then it's like a Pac-Man effect that you could go from here to here. Only on the vertical sides. The horizontal sides, you could still fold them, and that would be even more like a spheric thing. But we're not doing that, just for simplicity. And so, what effect does it have in the distance? Well, if you consider the distance between this point and this point, you could first be tempted to say that it's 1, 2, 3, 4, 5, and 6. But they're actually, closer in this new metric, in this new way to, to measure points. They're closer because you can take this route 1, 2, 3, 4, or you could also do 1, 2, 3, 4, etc. And so the distance between these 2 points is 4. Let's keep looking at examples. That's going to be the key to, to understand this puzzle at the beginning. Do lots of examples with your students, ask them questions, different things, and not just the answer, but the reason. And there's a lot of visual here. This point and this point are just 2 units apart, 1 and 2. So pretty interesting. And the final example I want to make in this video before we actually go to the problem itself, this point and this point, what is the distance? I'll give you a couple seconds to think about. Is it 8? Is it 1? So you could also poll your students, do a quick poll. so that everybody has an answer. Okay, the answer is actually 0. The distance between these 2 points is 0 because you don't have to do anything to go from one to the other. You're just there. They are the same point. And if you ask what's the distance between a point and the same point, that's just 0. 0 energy, right? 0 things to do. Nothing to do, and you get to the other point. Anyways, let's move to this now problem. So the problems are very close together, very related. Draw your lights and build your lantern. So it's a very beautiful thing, and you can have a discussion on where would you use them. But this brings opportunity for arts. There's probably students that are very art oriented, and you want to bring this into the meeting. And then the question, what is the least number of gems that we should draw? So we want, remember, we want that every point it's covered by the light of the gem, right? That the gem is kind of shining or whatever, or reflecting, and it just has some power, some distance. So it cannot cover all the lantern, but it can cover a big region, a big zone. And the question is, how many do you need? How many gems do you need? Of course, if you put one in each grid point, you will do it. But it's more about, okay, what's the least, right? What's an optimal way? Let's look at the solution. And it's going to be interesting because we didn't include the full solution. That's going to be a per the question, but we included a lot of scaffolding. And so probably the first good strategy is let's forget about the folding. It's too much information, right? We already talked about this new distance, and then we're folding, and then we're covering with the least number of gems. So there's too many things going on. So probably let's go step by step, and let's just forget that we're in a lantern, and let's just say, okay, no folding. So if I place this gem here in the center, that would be a good, conjecture, or a good candidate for starting what would happen. So I place it here, and then remember, I'm just trying to see which points are at 4 or less distance. So this 4 here, of course. And there's a nice analogy, how far can it see, right? It can see 4 up. It can see also 4 down, but not anymore. So of course it won't cover the whole paper, but you could also get to this, right? Because it's 1, 2, and 3, up to here 4, and so on. We then get this very nice rhombus here, where the diagonal is 8, exactly 8. And that set of points, it's what we call the neighborhood, or the zone of vision, the region of vision, right? How far you see. So this is what it will shine, this gem here. So of course, one gem, not a good job, impossible to cover. You get a lot of points out of reach, right? This point here, all these grid points, they are not seen by the gem, right? They're out of reach. Because remember, P, our parameter, was equal to 4. Of course, if you change it to maybe 10 or 20 or whatever, well, one gem will be enough. With 2 gems, do a better job, and you can see the details here on what is this region here. So this would be this for this gem and for the other gem. So together they see more, but they're still don't cover lots of things, right? All these points here are not covered. 3 gems, still not good. 4 gems. So it's probably a good idea to place the gems here and here, not too high, not too low. So, low enough that they don't leave any gaps and can actually reach here. 1, 2, 3, 4. Okay, that's good. Same for this. 1, 2, 3, 4. Otherwise, if I place these 2 gems a little higher, they will leave these corners uncovered. And so it's bad because the other 2 gems need to go up and cover the upper part. So what I'm saying is kind of already chose a pretty good way to place my gems. And as you can see, they start generating these cover-ups, right? These regions. So this gem generates this, and symmetrically this. And we almost made it, but these 3 points, let me mark them in this line in the middle, right? These 3 points are almost seen by the gems, but not quite. So they're at a distance of 5. Let's see, 1, 2, 3, 4, 5. And this middle also 5. 1, 2, 3, 4, 5. So these are like blind spots, kind of like when you're driving and when you look at the rear mirror, you don't see everything. I think there's a zone or a point, some region that it's blind spots you don't see. So it's what's happening. So 4 is not the solution. We need to do more. But the good news is if we place, for example, a gem here, the 5th one, it would definitely see the 3 points that were, travel for us. And then you can do all sorts of variations and cover your sheet of paper. That's not the puzzle, but okay, it's a start. And we did it, so now we have a lot of more intuition, right? We have a base to build on. And now we have to add this new feature of the puzzle, right? This new aspect of the folding. So it's gonna be a lot of discovery learning for everybody, right? And don't lecture would be my, it's very tempting because if you already know the answer, you're gonna say, put the gem here or don't put it here. But just let kids struggle, ask questions, and here and then offer some mini hints or, focus maybe on this, or can you remove this gem or things like that, which is kind of what we did in the pair deck, just to illustrate the point. And so the pair deck question, one of the most important for this pair deck is, we discovered that if the grid is unfolded like a normal square, 5 gems was the solution, right? We just saw this, but now we fold the grid and we turn it into a cylinder. So let me illustrate here, right? By folding these 2 lines, we wrap this here, and now, it's a different space, right? Circular in one direction, right? The horizontal becomes a circle, and the vertical, it's still a line segment. So the metric has changed, right? As we were discussing in the beginning. And so we connect back to this slide when we were discussing distances, the first slide. Let's take a look, quick look here, right? So this, yeah, it's totally open. Hopefully in the pair deck, you can do better than 5. And the hint is that it can actually be done with less than 5. I use different colors for the gems and the regions they cover. But let's look at the example here, just to see how it works. If I place the gem here, I not only see this part of the rhombus, let's call it the normal part, kind of. Of course, here is cut, but since I'm folding, then I'm also going this way, right? 4 units to the right, 1, 2, 3.4. And so you see that this looks like a very normal rhombus when you fold it. If you fold a piece, it would look like a very normal rhombus, right? It's kind of what I would be doing here. You would just be rolling this and then getting here something like this. Anyway, so that's the region right there. How to describe it? It's like a tie now, like a bow tie maybe. But of course, this is just one of many options for placing the gem. So what would be a good place to cover a lot of space now? And how many gems would you need? Interesting puzzle. And so for those that are more interested mathematically in this is a branch called topology, and you could look for these topologies when we do some foldings, and there's all sorts of crazy stuff going on. So I hope you enjoyed and have fun in the meeting.